As of September 2021, there were more than 28,000 objects larger than 10 centimeters in Earth orbit, being tracked by the U.S. Space Surveillance Network, along with countless smaller objects. Should we worry? Stay tuned to find out more. When we think of space, the first thing that comes to mind is that space is big, really big. There are over 350 trillion cubic miles of space between 60 and 400 miles above the Earth. Given this, you would think that the chances of being hit by another object in this space are vanishingly small. Unfortunately, that's not the case. With 28,000 tracked objects in low Earth orbit, the chance of a collision is not zero. And that's just for objects above 4 inches in size. There are millions of objects smaller than this that are too small to track, and that's a significant problem. At 120 miles above the Earth, it's possible to be hit by space junk that's traveling at 7 to 8 kilometers per second. At these speeds, an object weighing just half an ounce would deliver over 800 joules of energy on impact. That's more explosive energy than a hand grenade. You can imagine how much damage this would cause to a spacecraft or satellite. So where does space junk come from? Unfortunately, it is created whenever a rocket is launched into orbit. It's very difficult to make this process totally clean. When you launch a satellite into orbit, everything from the booster to debris from pyrotechnic events and even flecks of paint go along with it. In 2007, China intentionally destroyed one of their satellites orbiting at 530 miles above the Earth. That event alone created an estimated 150,000 pieces of space junk over 1 millimeter in size. Given the fact that the International Space Station has had to maneuver dozens of times to avoid an impact, you can see that space junk has a significant effect on our ability to operate in low Earth orbit. So what are the solutions? First is something called orbital decay. It turns out that the vacuum of space isn't totally empty. There are small traces of the atmosphere even at the altitude of the ISS. In fact, the station needs to be periodically reboosted to keep it in its desired orbit. If that wasn't done, it would eventually re-enter and burn up due to drag. Now you might think that orbital decay would eventually clean up space. The problem is it takes time. A spherical object weighing just half an ounce would take almost 10 years to naturally decay and re-enter from a 120-mile-high orbit. From a higher orbit, it would take much longer. We're simply adding junk at a faster rate than it naturally decays out due to drag. That said, it's not hopeless. There are several programs that are under development that are designed to actively clean up low Earth orbit. Aside from making launches cleaner, engineers are looking at everything from space-based lasers and magnetic systems to nets and other devices to remove objects from orbit. Unfortunately, this work is still in development. In the meantime, space junk will be a significant problem affecting both manned and unmanned operations in low Earth orbit.